All right, we're back in chapter 15 trying to make us some money. And yes, I'm dancing as I hear the song. All right, so we're trying to find the profit maximizing price and quantity for a monopolist. What we're given is the demand equation and the supply equation. Now, that's normally what we need for a competitive market. But the next thing we're going to look at then is also our marginal revenue equation, because we need that for a monopolist as well. So I'm going to start by drawing a demand equation, just a downward sloping line. Now, we've done this before. Is if this is my demand, the y-intercept is at 200. It has a slope of -1, so the q-intercept is 200. My supply curve is going to start at the origin and come up with the same slope. There's my supply. Now my marginal revenue is also going to start at 200, but it's going to have a slope twice as steep as a demand curve. And so it's going to come over here, and it's going to cross the q-axis at 100. All right, so now we've drawn out our graphs, okay, with these here. And now we want to identify the profit maximizing amount. Well, let's go ahead and see what the rule is. The rule is marginal revenue equals marginal cost. And so that's this part right here. Okay, well, our supply curve is our marginal cost curve. So we set marginal revenue 200 minus 2q is equal to q. And now we're going to solve for q. By setting those two lines equal, we're going to find the quantity for the monopolist. So we get 200 is equal to 3q. Q monopolist is equal to 200 divided by 3. And that's 66.67. Okay, so now we have that point. And now what we do is we put that into our demand equation. So we take this quantity, and graphically what's happening is we're taking that quantity and just bringing it up here to this point. So we get P is equal to 200 minus 66.67. Which is 133.33. And that's the price that the monopolists charge. Jizz. I guess that's a plural. All right, so now we've identified our optimal quantity and our price with the monopolist. Now we can go a step further and identify the different areas of the curve real quick, the surplus. So here we have our consumer surplus. To calculate consumer surplus, it's 1/2 base, which is 66.67, times the height, which is the difference there, which happens to be 66.67. So I'll just do that on the calculator. So consumer surplus is 2,222.44. Now producer surplus is this area here. And to help us solve it, it's going to be helpful to separate it into two spots. There's this triangle and this rectangle. And so it would be helpful to be able to figure out what this spot is. So we put 66.67 into our supply equation, and that'll tell us this point. And so that point is also 66.67 because we put it in for Q and the P is the same. And so now we can find the area of those two triangles and add them up to get producer surplus. So producer surplus is equal to, I'll do this one first, 1/2 base times height. 66.67 is the base times the height, 66.67. That's this little triangle here. And now to do the bigger triangle, it'll be plus base times height, 66.67, times, see, 133.33 minus 66.67 is about 66 0.66. Some rounding errors, that's all right. And so we'll get, this is the same as this triangle above. So we'll get 2,222.44 plus 4,444.22. And then add that to plus 2,000. We'll get, that's kind of satanic, 6,666.66 is the total producer surplus. And lastly, we can calculate deadweight loss right here. To calculate deadweight loss, we'll need to calculate this distance here. And to do that, we'll just set our supply equal to demand. So 200 minus Q is equal to Q. And 200 is equal to 2Q. Q is equal to 100. So this is not quite drawn to scale. I guess that should have crossed right there. I apologize. So we can just make this a dotted line that's straight right there to 100. But anyway, so this distance right here is 100. The height right here is 66.66. And so you multiply that, and then deadweight loss is 66.66, or rather 6,666 is our deadweight loss. And so there we can calculate the different areas within a profit maximizing